Hi everyone, welcome back to our channel once again. In this video, we are going to study about what we have already learned in the RC circuit part 4 video. You can audit the video with the link given below in the comment box. And for those who haven't had the chance to watch the video, I'll quickly recap what we are expecting in this video and what is the input we are giving to the RC circuit and the expected output at the capacitor. So to begin with, the circuit what we are trying to simulate is a RC circuit with a pulse input here, plus and minus. This is the pulse, and here we have a R and a capacitor C in series with it. Okay. Resistance is 1 kilo ohm and capacitance is 1 microfarads. Now the input signal what we are trying to give is T on is 0.1 and the T off is 10. Okay, so the period is 10.1. Okay. So it would look like this, and so on. It will keep going. So if you consider the one time period, this from here to here, so this part, this one is 0.1 and this one is 10. So total time period is basically T equals 10.1 millisecond. So time period is 10.1 millisecond and the pulse width WP or T on is 0.1 millisecond. And the tau we can calculate by multiplying the R and C, which gives us 1K into 1 micro. That boils down to 1 milliseconds. Okay. So what we can conclude from here is the pulse width is 0.1 millisecond and the tau is 1 milliseconds, which is 10 times. The pulse width is 10 times lesser than the tau, right? Time constant. It means that what does the tau represent in general? It represents that it requires 1 milliseconds to charge 63% almost, right? But what we have is just 1/10 of that. It means the capacitor will not be completely charged given the time, given the pulse width or P on. So this is 0 volt and this is 9 volt. Okay, we want to, so at the input we are giving this pulse and we are expecting the output here at the capacitor. As we have discussed in the RC circuit series part 4, the waveform would be something like this. It has very less time to charge, like 0.1. So the waveform would something look like this. It will be going up and it will decay. Okay, so this is 0.1 and let's say this is 10 millisecond plus 10, so 10.1 millisecond. So the expected output will be something like this. It will be going up, and so it will never be completely charged. It will be somewhere here. And the charging equation, we know that the voltage across the capacitor would be nothing but the maximum voltage it has is 9. So 9 into 1 minus e power minus t by tau, and tau is R into C, which is 1 milli. So you can write down 1000 t. Okay. So now if you put t equals 0.1 here, you can get the value as and that will be somewhere near 0.8565. Okay. So after first charging for 0.1 milliseconds, we will be getting something like this. So when we can say that there is switch here, which we close it, then capacitor will start charging, and after 0.1 milliseconds, it will attain certain voltage, which would be equal to 0.8565 volts. Okay. So it can never go above this, right? So it will discharge from there, and again, the charge and discharge, this will keep happening periodically. So we'll try to simulate the same thing in the LT-Spice and figure out how the waveform looks like. We'll try to analyze as well in the LT-Spice.